Good morning. Welcome to the video report of the term project of Dynamics of Machines as part of the coursework in the Department of Mechanical Engineering at IIT Kharagpur. This report has been prepared by three students, Praveen Yadav, Vineet Nangia and I, Prajwal Yadav, with our roll numbers mentioned below. This report contains voiceovers from all the members. The problem statement that we had to solve and make the report was to model and analyze a single cylinder IC engine considering practical values of mass of piston and links, cylindrical pressure variation, etc. We also had to check the ground shaking forces and performance without balancing and with balancing and flywheel. Firstly, coming to the importance of the problem, IC engine is one of the most important inventions that revolutionized power generation, and hence it is important to know its working in detail. The basics of dynamic and kinematic analysis can be applied to this mechanism even though the actual mechanism is very complex, and we are able to observe the practical side of the theory of dynamics of machines. Practical application of theoretical problems is something that is very important with regards to the skills that should be possessed by an engineer, and solving a problem like this helps us improve this skill. For these reasons, this problem statement is important for all overall development of a mechanical engineer.
Moving on to the modeling approach, we first considered all the input parameters that are required to perform the analysis and used them to perform kinematic analysis of the entire mechanism to obtain parameters such as velocity of piston among others. These output parameters were then used along with the input parameters to perform force analysis of the entire mechanism. In order to properly analyze the IC engine, we decided to choose a readily available design and infer all the input parameters such as the lengths of the linkages, the masses, etc. using that. A computer-aided design model was made and the dimensions were calculated using SolidWorks. The CAD model used is shown as follows. Now I will talk about the various input parameters that we used to perform the analysis. Firstly, we used time, which was represented by the letter T. We used stiffness of a virtual spring, which is represented by the letter K. We used the radius of gyration, which is represented by the letter Kr. We used the mass of link 2, which was M2, and the mass of the piston, which is represented by M4. We also have the lengths of link 2 and 3, which are represented by L2 and L3. We have the offset, which is represented by EV. We have the torque, which is represented by tau, and we have the coefficient of drag represented by CD. Here on this slide, we can also see a schematic of the single cylinder slider crank mechanism.
So now, moving on to force analysis, in order to remove the complexity of shape and design of components of the IC engine, we must simplify the model, and for that we should perform force analysis. It is observed that we can replace the link with masses with a dynamically equivalent model to get a good estimation on the forces experienced by the IC engine and the piston. We simplified the two links L2 and L3 and replaced them with masses placed on the two ends. We also considered the common node while making these calculations regarding the weights. So now, coming to our approach of calculation of masses of the dynamically equivalent model, we initially consider the link 3 and obtain the mass M3A and M3B using the following calculation, like M3A must be M3 multiplied by LB divided by sum of LA and LB, where LA and LB represent the distance of two ends from the center of gravity of the link 3. In same way, we can find masses m2a and we can find the effective mass at point A and point B. That is, MA must be equal to m2a plus m3a and MB must be equal to m3b plus m4. Now, after finding the masses of dynamically equivalent system, we can proceed to the calculation of shaking forces. The ground shaking forces were obtained as follows, where MA and MB represent the masses calculated in the previous slide, and Fsx and Fsy are the components of the ground shaking forces in the x and y direction respectively. Now, coming to analysis part, these are our results, which include graphs of variation of theta, variation of displacement of piston, variation of angular velocity, and variation of linear velocity of piston.